Okay, hello class. So this is your first try for expansion of product of algebraic expression. Okay, so technically speaking, alright, your quadratic expression is called quadratic expression because there is an x square in the expression. Okay, so remember that x square is basically when there are two x's that multiply with each other, right? And this is the short form of writing the result of that multiplication, right? So do remember that in sec 1 when we revise multiplication of algebraic terms, right? So for example, we have 3 multiplied by a, we will get 3a, right? A multiplied by a, we will get a squared. Okay, and then after that we had the linear expansion of algebraic expression. So maybe something like 3 a minus 2. Okay, so 3 is the only term outside the bracket, so we multiply into the bracket, so we get 3a minus 6. Right, so the 3 multiplies with each term in the bracket. Okay, so you also have terms like minus 2 multiplied by a plus 1, for example. So minus 2 multiplied by a, you will get minus 2a. Minus 2 multiplied by plus 1, alright, you will get plus times minus is minus 2. Okay, now before we can use expansion using special products, right, technically speaking, these special products just infers that when you see this expression a plus b square, a minus b square, a plus b bracket a minus b, okay, they always equals to a certain expression, right? But before we move on to that, let us learn about this one. Okay, now if we were to get an expression multiplied with another expression, for example x plus 1, x plus 2, right, you can use it, you can expand them using the same logic as your double digit multiplication. For example, 23 multiplied by 11, right, you have 3 times 1, 2 times 1, so you get 23. Then you 3 times 1, 2 times 1, then you get 23, but now the 3 is in the tens column, right? So when you add them together, this one bring down 3, 5, 2. Okay, so your expansion for algebraic expression is the same, right? So you have, let's say, x plus 1 multiplied with x plus 2. Okay, let's change it to y to avoid confusion. Right, so now you have this 1 multiplied by plus 2, so you get plus 2. Then y multiplied by plus 2, you get plus 2y, right? Then similarly, you take plus 1 multiplied by y, you get plus y, and y multiplied by y squared. Add it down the column, you get a plus 2 plus 3y y squared. Okay, so this is your answer, right? This is the result of the expansion of two algebraic terms. Okay, now usually we won't present our working this way. Okay, what we do is we follow the example here. Okay, so technically speaking, what you realize from this working is that each term in y, the term y plus 1, both multiply y plus 2. Okay, so that means we take a multiply with x plus y here, we get a bracket x plus y. Then we take b multiplied by x plus y, and you get plus bracket b x plus y. Okay, and then you do the usual expansion, right? Okay, just like the example here. Now, an even faster short form of this is what we call the rainbow method, where we get a plus b bracket x plus y. So we just do this because we know that a has to multiply both terms in x and y. A times x, ax, a times y, ay, b times x, bx, b times y, by. Right, and you will get the same answer as here. Right. Okay, next one. Moving on up to here. Right. So once you understand that how to expand this, we go back to expansion using special products. Now you notice that a plus b squared, right, is a plus b times a plus b, right? So because this multiplication will always give you the form a squared plus 2ab plus b squared, right? So this is called one of the special products because they always give you the same form, right? I think from here, let us try a few questions to practice our expansion before we come back to this expansion using special products. Okay, so let's look at question 1a. So from here, we have an x, bracket x plus 5. So naturally, we just take the only term outside the bracket, multiply with both terms inside the bracket. So you have x plus 5. Your answer will be x times x is x squared plus 5x. Right, so this will be your answer, x squared plus 5x. Right, so taking this thinking, we move on to the next one. Now we have a minus 2 here after we do our expansion. So let us do our expansion at the side here. 3z plus 1 multiply, okay, remember the square means 3z plus 1 multiply with 3z plus 1. Okay, so from here 3z multiply with 3z and 3z multiply with plus 1, or you can say that 3z multiply with 3z plus 1 straight away. It's the same thing either way. Okay, this is what we discussed earlier as the long method. Then you take plus 1, you multiply both. Right, so you get plus 1 multiply 3z plus 1. Okay, so from here we expand 3z times 3z, 9z squared. 3z times 1 plus 3z. 1 times 3z plus 3z, 1 times 1 plus 1. So it's 9z squared plus 6z plus 1, right? So we sub this back into here. Okay, we already have here 9z squared plus 6z plus 1. But don't forget there's still a minus 2, right? So plus 1 minus 2, 9z squared plus 6z minus 1, right? Okay, hopefully you are able to follow. Okay, next one. Now they ask you to expand and simplify 3x plus 2p. So we have 3x plus 2p times, this is a square, so we know there are two 3x plus 2p and they multiply each other. Okay, so if we use the following expansion, 3x multiply by 3x plus 2p, we get 3x bracket 3x plus 2p. Then we got 2p multiplied by 3x plus 2p also. So we plus 2p bracket 3x plus 2p. Expand it. 3x times 3x, 9x squared. 3x times 2p plus 6px. 2p times 3x plus 6px. 2p times 2p plus 4p squared. 9x squared plus 12px plus 4p squared. Okay, so that will be your answer. Alright, now moving on, they say that given that this 3x plus 2p bracket square equals to 9x minus 48x plus 64, find the value of p. Right, so if the value is the same, that means 12px, 9x squared plus 12px plus 4px squared should equals to 9x squared minus 48x plus 64. Right, so you compare coefficient. For example, 9x squared, 9x squared. Here is an x, here is an x. Right, and this is a number, plus 4p squared, this is plus 64. Now, take note, even though down here is plus 4p, and this is minus 48, because when you compare coefficient, if everything else is the same, then plus 12p must equals to minus 48. So p could be a negative number, right? So by comparing coefficients, you got 12p equals to minus 48. Minus 48 divided by 12 minus 4. Okay, but just to double confirm, we equate the other one, 64. Divide 16. So remember, the reverse of square is square root. So square root 16, you get plus minus 4, right? You can use your you need to use your calculator for this one, square root 16. But take note that square root 16, the square root of any number will usually have a positive or negative value. This is because minus 4 bracket square will give you 16. 4 square will also give you 16. Right, so if minus 4 bracket square and 4 bracket square can both give you 16, then square root 16, right, can give you the answer of either plus 4 or minus 4. Right, but based on our previous working, p is minus 4. Okay, right, so from here we move on. Question 3. Okay, now take note. Some of you may be confused and think that, oh, this is an expression, but the thing is there's no bracket here, right? The only thing outside this bracket, this term, the bracket of this term is just minus 3. So only minus 3 actually multiplies in. So the answer here would be minus 3 multiplied by x minus 3x. Minus 3 multiplied by 2 minus 6. Right, x minus 3x minus 2x minus 6. So your answer is minus 2x minus 6. Alright, then when you come to this question here, now you have to do double. Okay, so the one thing to take note is the negative sign here. Okay, because remember, when you multiply the negative sign in, it will change your sign of your terms. Okay, so don't be overwhelmed by so many terms. Okay, just know that we need to expand it we need to handle each expansion separately first, right? Then we will multiply in the negative sign for the one at the back here. Okay, or the one at the back here. So expand as per normal. 2a times a, 2a times minus 2. 5 times a minus 2. Okay. Right. So down here again, 3a expand 2a minus 5 plus 2 expand 2a minus 5. So from here, your normal expansion will give you 2a squared minus 4a plus 5a minus 10. 6a squared minus 15a plus 4a minus 10. Right. Okay, now take note, this part is where you need to be careful, because now we are going to multiply this negative sign into this whole equation here. Okay, so I'm going to remove this one. Okay, minus 4 plus 5, 2a squared plus a minus 10, right? So minus 4 plus 5. Now multiply this in negative times 6a minus 6a squared, negative times minus 15a plus 15a, negative times plus 4a minus 4a, and negative times 10 plus 10. Okay, so take note, there is a change in the sign for every term in this bracket because you multiply the negative sign in, right? Even for the first term, 6a is originally a positive. Okay, now add the like terms together. So we have 2a minus 6a, so you get minus 4a squared plus a plus 15 minus 4, right? So you get plus 16a plus 12a. Lastly, plus 10 minus 10 is 0. So this will be your final answer. Okay. Right, then for this question, give this a try. And then we will go through in the next lesson. Okay. Any questions, please ask. All right. Thank you.